You open a banking app while you're supposedly in a country it wasn't built for, or on hardware it doesn't recognize, and you get one of three things: a blank error screen, a vague please try again later, or a silent logout with zero explanations. No code to look up, no reason given, nothing. That's not a bug, that's the design. And once you know what's actually being checked, the whole thing stops looking random. Run a cloud Android phone farm out of Singapore, dedicated hardware, wrecked and running around the clock, not one test phone on a desk. I spend my days watching which sessions clear a bank's checks and which ones get flagged before the login screen even loads. So I've had a lot of time to work out what's actually happening under the hood and why some setups pass every time while others never stand a chance. Most of the gatekeeping in a banking app happens before you ever see a password field. The app calls Google's Play Integrity API, and their API hands back a verdict built from three things. Is the app itself unmodified? And from Play, is the device recognized as a genuine unmodified Android device? And does the device pass hardware-backed attestation through its trusted execution environment? Google actually splits that verdict into tiers: meets basic integrity, meets device integrity, and meets strong integrity, and the banking app usually won't show you a login screen unless it sees the top tier. The top tier is the one that decides everything. Hardware-backed attestation asks the device's secure chip to sign a statement saying it's running on real hardware. A virtual machine has no chip to ask, so it either fails outright or comes back with a weaker tier of trust, and fraud systems downstream are built to treat that weaker tier as a red flag before they even look at anything else about the session. On top of that, the app checks for root, checks whether the bootloader's unlocked, checks whether a debugger's attached. It reads the build fingerprint, a long string naming the exact device model, maker, and firmware. It reads the GPU renderer and vendor strings. It watches how sensors behave over time. None of this is exotic. Any Android developer can wire it up in an afternoon, and most banking teams do exactly that. What makes it effective isn't any single check, it's that they're stacked. Fake one signal and you usually leave three others exposed. A setup that fools the fingerprint check might still fail on GPU strings, or on sensor noise, or on the attestation tier itself. Banks don't need one perfect check, they just need enough disagreement between signals to justify a block, and stacking checks is the cheapest way to guarantee that disagreement shows up. We've tested this stacking on our own devices more times than I'd like to admit. Spoof the fingerprint and the sensor behavior catches it. Get the sensor noise close enough and the GPU renderer string still gives it away. There's no single setting that gets a fake device past all of it at once, which is exactly the point of building the checks this way in the first place. None of this is really about App Store quirks. It's about regulations. A bank licensed in Singapore has to run Know Your Customer and anti-money laundering checks that assume you're physically there, holding a SIM registered there on a device that behaves consistently with that story. Regulators like the Monetary Authority of Singapore expect the bank to tie account activity back to a real person in a real place, and the phone is the cheapest, most reliable way to prove that. Two-factor codes sent over SMS only mean something if the number receiving them is tied to a real local SIM, not a number that could belong to anyone anywhere. If the app let people log in from anywhere with no location or SIM correlation at all, the bank couldn't meet its own compliance obligations, and its license would be the thing at risk, not just some account somewhere getting flagged. It's not just regulators driving this either. Fraud teams have their own reasons to want the same signals lining up. Account takeover usually shows up first as a device or location that doesn't match the account's normal pattern, long before any money actually moves. A fraud team watching for stolen credentials being used from unfamiliar hardware in an unfamiliar place gets the exact same signal a regulator would want to see, which is part of why banks invest so heavily in getting these checks right in the first place. So the region lock isn't paranoia, it's the bank protecting the thing that lets it operate at all. And the enforcement happens a few ways at once. The Play Store account doing the download has to be registered to that country. The SIM inserted has to belong to a carrier operating there. The network path has to resolve somewhere consistent with both of those. None of those checks alone is bulletproof, which is exactly why banks stack all three instead of trusting any one of them. Fastis ingin to be penjite to speech tipin and postisim. Disibeni tapens thoughts. Disibenition, besides come, this the same way almost every time. First, there's no real trusted execution environment to ask. Play integrity's strongest tier needs a hardware-backed key, and software running as a virtual machine on a server has nothing to offer that isn't itself virtualized, which is exactly what attestation was built to catch in the first place. Second, the GPU renderer string gives it away almost as often. A real phone reports its actual chipset's graphics driver, something like a Mali or Arduino string tied to real silicon that Google's own device catalog recognizes. A virtualized graphics stack reports a software renderer instead, and that string alone is often enough for a fraud model to flag the session before it even checks anything else about the account. Third, sensors behave differently. A phone sitting on a desk still produces a small amount of accelerometer and gyroscope noise from vibration, thermal drift, and imperfect calibration. None of it intentional, all of it real. A setup with no physical accelerometer either reports nothing at all, reports a flat line, or reports suspiciously round numbers no real sensor ever produces. That noise pattern is cheap for a bank to check and genuinely hard to fake convincingly over time. Fourth, the build fingerprint often doesn't match anything that was ever actually sold. Real devices ship with a fingerprint tied to a specific model, region, and firmware version that Google has certified. A setup that isn't running on certified retail hardware usually reports a fingerprint that doesn't exist in the wild, or one that belongs to a device whose screen resolution and radio configuration don't match the rest of the story it's telling. None of these checks are foolproof on their own, and a bank knows that too. It doesn't need certainty, it needs enough inconsistency across the layers to justify a block, and a virtualized setup tends to generate inconsistency at every layer at once, not just one, which is exactly why it almost never gets a clean pass. Real hardware changes this at every one of those points. A real device has an actual trusted execution environment, so attestation comes back as a genuine signed statement, instead of failing or dropping to a weaker tier. The GPU renderer string is whatever chipset is actually inside the device, because there's a real GPU driving the screen. Sensor data has the small physical imperfections that come from an accelerometer sitting in an actual enclosure, and the build fingerprint matches a device Google actually certified because that's the fingerprint it shipped with from the factory. That doesn't make every check disappear though. A device check is only half the picture. If the phone's IP, SIM, GPS location, and system time zones don't agree with each other, or don't agree with what the account claims, the location half still catches it regardless of what the device reported. A real phone in Singapore with a Singapore SIM and Singapore time zone settings looks consistent because it actually is, not because one clever trick fooled one specific check. People tend to focus on the device check because it has clean technical hooks, attestation, route detections, sensor data, things you can point at. The location check gets less attention, but it's just as strict. Banking apps compare IP geolocation against GPS coordinates, against the SIM's home network, against the phone system locale and time zones. Disagree on any two of those, and you get flagged no matter how clean the attestation looks. Every device we run carries a real Singapore mobile IP, a Singapore SIM, Singapore time zones, and Singapore locale, all at once, all the time, because the moment any one of those drifts out of sync with the others, the account looks less like a person and more like a problem. That alignment isn't the trick. It's just what a normal phone belonging to a normal person in Singapore actually looks like from the outside. This is why running a business account or a QA account for testing a region-specific banking flow, or a client account tied to a different market is genuinely hard with one physical phone in someone's pocket. You need a real device on a real local network with a SIM from that market, kept in a stable state over time, not bounced between locations in a way no normal traveler's pattern would ever look like. That's an operational problem, not a clever technical trick. The people who actually run into this problem legitimately aren't trying to trick anyone. They're an expat trying to keep a home country bank account alive while living abroad. A fintech QA team that needs to test a region-specific banking flow before it ships, or an agency managing client accounts across several markets at once. None of them are looking for a shortcut around a bank's controls. They just need a real device that genuinely belongs to the market the account is tied to. And that's a hardware and logistics problem long before it's ever a software one. If an account keeps failing a device check, work through the layers in order instead of guessing at which one it is. Confirm the play integrity verdict the device is actually returning, not just whether the app opens without an error. Check whether the SIM matches the country the account claims to be in. Confirm the time zone and language match. Check whether the Play Store account itself is registered to that country. Check whether the IP resolves to the same country as everything else. One mismatch is usually enough on its own, and fixing the device without fixing the location, or the other way around, still won't get you past the bank checking both at once. None of this is about beating a bank's fraud controls, and it was never meant to be read that way. It's about understanding that the controls are layered on purpose, and the only setups that pass consistently are the ones where every signal, hardware, sensor, network, and location actually agrees with the story the account is telling, every single time it's checked. That's the exact problem we built our setup around. What we run are real cloud Android phones in Singapore on dedicated hardware, each one with a persistent SG mobile IP, so the device and the location tell the same story every single time someone checks. If you want to see what that actually looks like, look up cloud.one. If this was useful, subscribe for more of this, and I'll see you in the next one.